So let's look at one like number 11. We're going to look at part A, and then we'll do part D and E. This is very similar to the expression you see in 11A, just change the numbers around a little bit. The summation notation, pretty easy again. This is a Greek letter capital sigma, which stands for sum. And we're summing from I, we say equal 1 to 4. So I is the index. It's a variable, but we called it index. And so it starts at 1, ends at 4. The increment is always one unit, okay, one value. So this would start at I equal 1. And all I do is I take this expression and replace I with 1, which I've done here. So I equal 1, I replace the I with 1. So I got 4 times 1 squared minus 3, which will be what? 1 squared is 1. So I get 4 minus 3, which is 1. Okay, but then I'm going to add then the result when I is the next value. So what's 1 more than 1? That's 2. So I equal 2. So I replace I with 2. And then I equal 3, right? I replace I with 3. And then finally I equal 4. And that's where I stop because that's the top number. So I'm just adding these 4 expressions together. I've evaluated each expression. So this comes out to be 10. This comes out to be 27. This comes out to be 52. And then I add those all up and I get 90. So this sum is equal to 90. So summation notation. Okay. In D and E, I'm going to look at ones very similar to that. In part D, basically you're summing, it looks like just a constant. There's from I equal 1 to 12 here. And there's no I in this expression. So what's that mean? Well, when I is 1, you get 3. What's next? I is 2, you get 3. There's no I with this. So it's just going to be 3 every time. You're just adding 3 up how many times? Well, I equal 1, I equal 2, I equal 3, all the way to I equal 12. There's 12 3s. So how can I add up 12 3s? Well, I can just multiply, right? Adding 12 3s up is 12 times 3. Which is 36. And in fact, this gives us a general rule, which is true for any summation from I equal 1 to n of any constant is just n times that constant. And that's going to be important later when we do summations where the ending value for our index is going to be arbitrary, going to be n. It's going to be n, some arbitrary value. So you can see it's just n, which is 12, times C, which is 3 in this particular example. Now I contrasted that in part E with one like this, I equals 0 to 8. So what's happening here? This index starts at 1. We do that a lot, but we could start at any value. You could start at 0. I can start at 4. I can start at whatever value, and then we increment by 1 each time until we get to the top. Okay, so what happens here at I equals 0, the value is just 4 again. So here the constant here is 4. In this case, when I is what's 1 more than 0? Well, 1, right? So when I is 1, we get 4. When I is 2, I get 4, and so on, all the way until I is 8. Now, how many 4s do I have here? I don't have 8 of them, right? Because I've got 1 more than 8, right? I got 1, 2, 3, 4, 5, 6, 7, 8, and then I equals 0 is the 9th one. So there's actually 1 more. So it's 9 times 4 because I started at 0. I started with I equals 0. So I get 36. And so in general, this is saying if you're starting from 0 to n, it's going to be 1 more than n times the constant, right? Because you got that I equals 0. So if you change the starting point for the index, that's going to change the way these sums work, right? So if I had summed, say we'll do one more. If I did the summation, I equal, say, 5 to 8 of 4, well, I equal 5 is where I start. I equal 5, I get 4. I equal 6, I get 4. I equal 7, I get 4, and I equal 8, I get 4. I'm just adding 4 4s, I get 16 there. So you see the difference there. So, be careful to watch that. Now, 99% of the time, with the sums we're going to be doing, we're going to start at I equal 1 for the problems we're going to be doing here. But you can also have sums to start anywhere and end anywhere. And so you want to be aware of that, especially in these type problems. Hopefully this helps.